Okay, we're down to the last few problems here. This one, based off of the same concept as the ones we had to graph a little earlier when we were graphing a linear function. This time you're supposed to recognize that this x squared, instead of it being a linear, now it's going to be a quadratic, so we can answer the parent question as a quadratic. So that means that when you graph this thing, you should be saying to yourself in your head that you need a parabola type shape. So the way we get that is having to get 5 points to make it correct. So we get those points the same way that we did for the linear one, except this time, instead of using just the 0 and 1, I'm going to use the 2, so I have a couple positive ones. And I also want to use a few negative x values. That way I get both the right side for the positive one and the left side of the graph with the negative number. So I get the full shape that I want. So I'm going to take that 0 and put it in here. 0 squared is still 0. 0 minus 3 is negative 3. If I put the 1 in here, 1 squared is 1. 1 minus 3 is negative 2. If I put the 2 in here, 2 squared is 4. That's 4 minus 3, that's equal to 1. Here's the part where people mess up because they use a calculator a lot. Normally I would advise you against doing that so you don't make a mistake that's really silly. Negative 1 squared is positive 1. Positive 1 minus 3 is negative 2. And here again, negative 2 is squared is positive 4. 4 minus 3 is 1. So sometimes when people enter that into the calculator, they forget to put the negative in parentheses, and so when you square it, you end up getting the number squared and then made negative again. And so for example, if you enter this in like that and enter it incorrectly, you end up getting negative 7 rather than the correct answer of positive 1. So it's time to graph this whole thing. So I need to put on 0, negative 3, 1, negative 2, 2, 1, 2, negative 1, or sorry, negative 2, 1, and negative 1, negative 2. Then I can connect that in. I have my graph. Now the last part of this asks you what transformation occurred. So compared to the original function, compared to the parent function, how is this graph different than what it's supposed to normally look like? Well, one of the major things is that parent function starts off at x is 0, 0, and then goes up this way. So it's obvious that this one doesn't start at 0, 0 anymore. It's to move down 3 places. So moving it down 3 is called a translation. So we are translating down 3. Okay, we're into some of our last parts. This is the most recent thing we've done, which is probably a review for most of you, which is great. So we're solving equations. Generally the method is to try to get x's or whatever the variable is by itself. So in this problem, we're going to start by getting the variable term by itself. So I want to get rid of this positive 7 by subtracting it away. That's going to leave me the x over 5 here. Negative 1 minus negative 7, negative 1 minus 7 is negative 8. And then the last step I'm going to do to get rid of this divided by 5 part, now I'm getting the variable by itself. It's going to multiply by 5 on both sides. And that's going to give me negative 40. When we get over to number 39, now we're looking at one that has a little bit more complicated setup to it. It has some distributing involved. Here again we have a negative 3 that needs to be multiplied through here. We leave the 12 alone for a second, and we get negative 3w and negative 27, negative 21 equals 15. Now a lot of people I noticed been watching you guys do your reviews, where they like to start adding 21 to both sides and then subtracting 12, and then finally maybe dividing. The idea is that you should combine the like terms before you get to moving stuff around from side to side. So this positive 12 and this negative 21 should really combine to be negative 9. Now it's very easy. Now you can just say to yourself, all right, I'll add 9 so I can start getting the variable term by itself. And then I'm going to divide away the negative 3 so that I can get the w by itself. I end up with w equals negative 8. All right, and the last one of these equations is one where we have multiple distributing going on. We have variables on both sides of the equal sign. Lots of stuff, trying to confuse you, trying to make it a hard problem. But if you keep in mind that the steps are always the same, it's a very, very set up and kind of canned procedure. And so here, 32, I'm going to leave it alone for a minute. Now I've got positive 4 times this stuff. So I've got 4c, and 4 times negative 1 is negative 4. Now over here I got a negative outside of the parentheses here. I can treat it like a negative 1. Negative 1 makes that negative 4c. And negative 1 times that makes that negative 5. So here again, I've got some issues here because I have variables here and here. I've got numbers here, here, and here. Well, I want to try to combine some like terms before I start moving stuff left and right. So this side over here, 4c is okay, but 32 and negative 4, that gives me positive 28. Okay, in this case, it doesn't really matter what side you get the variable to end up on. So I'm going to get rid of this negative 1. So I'm going to say take 4c to both sides. That's going to give me 8c plus 28 equals negative 5. Okay, so now I've got one variable there, which is nice, but I need to get that term by itself. I'm actually going to bring this problem up this way. So in this case, I'm just going to rewrite it real quick. I'm going to subtract the 28 because I want the variable term by itself. That's 8c. And now we have negative 5 minus 28. So that's negative 33. And finally, to get the variable by itself, I'm just going to divide by 8 on both sides. Okay, the problem with this is that a lot of people freak out when they see that this doesn't work out to a nice easy number. I don't want a decimal answer. So because this doesn't reduce, I guess you could make it a mixed number if you like, but I don't even really ask you to do that. So all I'm saying to you is take this and leave it as your answer since it doesn't reduce. Okay, we're down to the last two problems. This time we're solving inequalities. In this case, they work very much like equations, except that there are a couple simple rules that I like to follow. One is that I always want my variable term to end up on the left side because it makes it very easy for graphing on a number line where there's no mistakes. The other thing is that I want to remember that if I ever divide or multiply by a negative in my last step, that I have to reverse the inequality sign. So let's see what's going to happen here. There's no distributing or anything like that, so this is a relatively easy one, but I do have variables on both sides. So like I said, I want it to end up on the left. So normally I might actually take the 9x over here, but instead I'm going to subtract the 12x. That's actually going to give me negative 3x over here, which brings in a negative that I don't really want, but that's kind of what happens when you deal with that, get the variable on the left all the time. Okay, now I want to get that variable term by myself, so I'm going to subtract 4 away. And now I've got negative 3x is less than negative 11. Sorry, I gotta back that up. That's not correct. Simple mistake. But could change the whole outcome of the answer. So negative 11 minus 4 is negative 15. Okay, one more step, and I'm going to, again, write it up here one more time. Is that I'm going to divide everything by negative 3. So this is that last step I was talking about. I'm dividing by a negative. So this is where I get an x here, and this is actually now positive 5, and this is that time where you change the sign around. So in this case, now I'm going to finish my solution by saying I have x is greater than 5, and then drawing a very simple number line. I put the 0 here, and I know the 5 is going to be over here. Now this tells me that there's no equal sign, so it's going to be an open circle on the 5. And then greater than, well, again, one of the things for the variable being on the left is that the arrow always points in the direction you're supposed to shade. But if you really want to understand this, greater than 5 says, give me all the numbers that are greater than 5. Well, where is 6, for example, on this number line? It would be over on this side, so I need to shade this way. So I'm going to keep that in mind for this last one, which is obviously maybe the most complicated problem we have on the whole paper. This time we have distributing here and over here. We're going to combine like terms. We have variables on both sides. Everything you can probably think of to put in an inequality problem is in this problem. So let's get to work and try to finish it, and then we'll be done. So I'm going to distribute over here 5x minus 10. I'm going to distribute in here 8x plus 24. And I have that plus 2 on the end. So this all is going to stay the same for a minute while I combine the like terms on this side. 24 and 2. What's this that? Okay, again, I don't want the variable to end up on the right, so I'm actually going to subtract the 8x away from this side and this side. So, in this case, when I have this subtraction over here, I have negative 3x minus 10 greater than or equal to, now this is gone, so I have this is 26. I want the variable term by itself, so I have negative 3x, and I'm going to add 10 to both sides of here. So I now have greater than or equal to 36. And this last step, here we go again, negative 3x greater than or equal to 36. I want to divide by negative 3 because I'm doing that. The sign will switch around one more time. So our final answer is less than or equal to negative 12. And on a number line, I put 0 here, negative 12 here. It's an equal to symbol, so I want a closed circle. And less than, the arrow points to the left, means I shade to the left. And if I think about it, numbers that are less than or equal to negative 12, negative 100 would be out here somewhere. It means I want to shade this way.